welcome to Cosmos with Cosmos. As always, I'm Mike.
I'm Liz.
I'm Brandon.
And we are sort of here, but not.
We're here.
We're here. We made it.
Between recovering from COVID and jet lag, we're somewhat... the three of our brains together can possibly equal one brain. Or have we'll find out. Partial lobes.
Today
it's
we're
like
going
the
to be
worst
talking about
episode
Venus,
of
so we'll
Captain
find out. I mean, it's going to be like doing Grand Tour with a little more in depth.
Okay.
Yeah.
Okay,
so, yeah. So let's just jump right into it.
Let's jump into it.
Liz, let's start with Brandon. Brandon, what are you drinking,
Sorry,
man?
I actually jumped and no one else did, and that's fine. So for my starter, I am drinking from my premium tea collection, Jeju Earl Grey, hot from South Korea.
Ooh, nice. I mean, it does sound delightful.
It's exactly what I need right now.
Yeah.
Unlike my second drink, which is not what I need, but I'm going to have it because Valhalla.
Hey, nice.
Let's go.
Nice.
What are you drinking?
I'm drinking a Venusian toddy, which is it's a hot toddy, but because of the color and the theme of the show, I'm calling it a Venusian toddy because Venus is hot. And then my second drink is technically it's a Gold Rush. All right, but I didn't think of a name for it, so it's a Gold Rush.
I like we have tea-based drinks, and Mike's going to change it up.
Yeah, what do you got?
I have... Oh, I gotta get it. I have what I'm calling the Blue Absorber.
Oh.
Ooh, nice.
Yes, and good, it does show as blue.
It does.
It's like a nice periwinkle almost.
Yeah.
Ooh, look at you.
In essence, this is a lavender gimlet. So it has gin, which all gimlets have, but gin, lime juice, and lavender syrup. So
Wow.
Oh, yes, I do. That's one of my new favorite drinks is a lavender gimlet. I had it last night. And I'm not a gin fan, so there's like 3 gin drinks now that I like.
Maybe you are a gin fan then.
Maybe
There are
I'm
3 gin drinks?
And my second drink is just cinnamon whiskey and cranberry juice.
There you go. Classic. Good classic.
Yeah.
I love it.
This tea is just so delightful. And as we would say in South Korea, Jen.
Chen.
All right.
Jack doesn't have a fancy drink, but that's okay. You don't have to have a fancy drink, Jack. We're just happy that you joined us. And then Katie's going to be trying some ranch water, some sort of hard seltzer that her and Anna have been wanting to try. You'll have to let me know what.
Is it like Valley Ranch drink or what?
Like, yeah, is it like ranch dressing or is it just like
it guzzling down the bottle?
It has to do with the theme of being on a ranch? I've never heard of it before. The ranch theme, not ranch dressing.
Yeah.
I don't know. People really like ranch dressing.
I mean, yeah, Brandon doesn't, but I do.
Anyway, you know what? She'll
What's
put it on. She'll put it on social media for you.
Mhm.
And speaking of social media, follow us on all the things: Twitter, Drinking Cosmos, and Cosmos on everything else. Follow us and rate us on everything: iTunes, Spotify, whatever.
Yeah, all those things that people use nowadays. I don't know.
And also, don't forget to join us for the Hangover if you are with us now. And if not, well, then I don't know what to tell you.
You can catch it later.
But don't forget to join us for the Hangover. And as always, check out Wildixia on Etsy, where you find all of Katie's great artwork. So it begins.
Look, I went far away from the microphone.
So Wildixia, IXIA, on Etsy. Also check out the Mr. Proctor Show, which is Ron Proctor. And if you are in the Council Bluffs area of Iowa, then check out Jack's Planetarium at Rolling Bluffs Planetarium. And you can find out more information about what they got going on at rollingbluffsplanetarium.com. Also, The Shot every 2 weeks on a Wednesday.
Yeah, we just had a new one come out about eclipses.
Very timely.
So check it out.
We drop a little, what is supposed to be 10 minutes, and sometimes we hit it, sometimes we don't.
We usually hit it or under.
Yeah, we do usually hit it. But
Me.
little shot-sized bits of astronomy. And also, as always, we have rules. If a puppy barks, they're all just lying together on a big
Is Jack on the bed with
Yeah.
Oh my god, he is.
on
Oh,
the
Jesus.
dog bed. They're lying together.
God.
But if they happen to bark, take a drink. Any Star Wars reference or Lord of the Rings reference, take a drink. And today, new rules. If any of us have a coughing fit,
That means a fit of cough, not just a single cough, like.
yeah, take a
but
drink.
like my
Understood.
coughs, I'm getting a dry one. It's a dry one.
I also have a rule. So next to my building is a new skyscraper being built. And I learned this the last 2 weeks while I was gone, but they put something in there to where if the winds kick up above 20 miles an hour, it sounds like a train whistle. Like you hear it for blocks, and I'm right next to it. So if the breeze goes above 20 miles an hour, we will hear a train whistle. Take a drink.
When there is no train, I like it.
Ghost train.
All
No,
right.
it's not. It's not fun at all.
So let's go ahead and jump right into Venus here.
But don't literally jump into Venus.
No, don't do that.
And
We'll
you'll find out why. Yeah.
We'll find out why. But Venus is one of those beautiful objects that are in our sky. Third brightest object in the sky. Only the sun and moon are brighter than Venus. And it has been obviously noticed by cultures and people around the world
Good for that.
for as long as people have written shit down.
I have a quick question.
Yeah, what's up?
Does anybody know why women are from Venus? Is it just because we're
You
so
gotta read the
hot,
book.
I don't know what qualities of Venus
Well,
attribute
it's just because it's
being...
beautiful. I'm sure it's because it's beautiful.
Oh, I thought it was from Jupiter to get more stupider, but I'm not sure what the Venus is.
Well, it's that book.
Yeah, men are from
women
Mars.
Venus,
Women
men
are from
Mars.
Venus.
But no, I think just through time, because of its beauty, it's just
And
been
they'll kill you.
associated with women.
Yeah.
Although
so will Mars.
Yeah, and so speaking of some of that, the Sumerians, it was Inanna, which was the goddess of love, war, and fertility.
Love, war,
and fertility.
I like that.
This. Yeah, don't fuck with women.
I mean, it makes sense,
you know.
Love can lead to war.
Yeah.
And if you're going to have a war, you probably need to replenish the soldiers, so you probably need to be in charge of fertility as well. So.
Wow.
So there's that.
There's lots to unpack there.
For the Babylonians, they called it Ishtar, which was associated with
like the Ishtar,
Inanna, also a goddess of love, war, and fertility. Okay. For the Canaanites in the same area, it was Attar, which was the male version of Ishtar.
Oh, okay. So a male Venusian twist.
Also had a great Lord of the Rings reference in there that no one heard, which is okay.
I didn't hear it, no.
It's like the Ishtari.
Okay, all right.
No, but we didn't list that as a rule. We didn't list that as a rule, did we? We said Star Wars reference, but we didn't.
And Lord of the Rings. It's always Lord of the Rings.
Yeah, always. I don't think he mentioned it this week though.
But no, it's still a given.
Oh, okay.
It's a given.
By
the way, just a little side note for nerds out there, like the two guys that are here with us today. They're MeUndies. I haven't had any MeUndies products because I get the Tomboy X, but MeUndies has a Lord of the Rings underwear edition out. Just FYI.
Is that what's spamming me on Instagram?
It might be, yeah.
Okay. Moving on.
Okay.
So Venus is seen always really close to the sun. Not like really, really close like Mercury.
Right.
But
you
it's
mean in our
always
sky,
relatively
like
close.
in our sky. It looks like
it's always relatively close to the sun.
Not too far.
And as the sun moves across the sky, Venus goes with it. And sometimes it can be seen in the early morning hours, and sometimes it's in the evening hours.
Does it have any nicknames?
Well, the evening star and the morning star.
Yeah.
So interestingly enough,
it's when you do the Starlight Starbright for Star I See Tonight, that's typically usually either Venus or Jupiter that you're making a wish on. It's usually a planet that you're
or an airplane.
But because it was seen in the morning sky and the evening sky, there were cultures that thought it was two different things.
I mean, it makes sense.
Yeah,
it makes total sense.
So the Egyptians saw it as the evening star as Uadi, and it was associated with Osiris and Horus. The morning star Tiamutiri.
You know, it's fine.
Which was associated with like a phoenix or a heron.
Yeah.
Oh, Phoenix Rising in the morning, I guess. I
Yeah.
don't know.
In China, it was Xinjiang, the golden planet of the metal element.
The Golden
Golden
Planet?
of the metal elements?
Yes.
That's fucking hardcore. I want that
God,
album.
the Chinese, their symbolism is just, so beautifully poetic and in-depth. It's a little extra sometimes, though.
Yeah. Vietnam also saw it as two different things. Morning star was called Mai. The evening star was called Home. The Maya, for the Maya, it was Chok Ek, the greatest star.
The greatest star.
You made it, guys. You're the greatest star. You made it.
Yeah. So, different cultures see different things for it. For the Greeks and the Romans, it was the bringer of light, the dawn bringer, Lucifer.
That's a weird sound, Brandon, that you got.
That wasn't the whistle.
Okay.
Oh, I didn't even hear it.
It was like ghost whispering.
Somebody's like sawing metal.
Oh, is that what it is? I don't know.
I think so.
Hose. Okay.
Oh my god.
Wait, I saw Lucifer on the notes.
Yeah, I just talked.
You just
about
said that? I got distracted.
Yeah, I said for the Greeks and Romans, it was the bringer of light, dawn bringer, Lucifer.
And Lucifer?
God,
Well, Lucifer Morningstar.
Lucifer Morningstar. And of course the Christians took that and ran with it.
Well, of course they do, because
devil and shit.
Oh, hail Venus.
Hail Venus. I'll drink to that.
All right, so that's how cultures have seen it.
Right.
But
because we didn't have telescopes or could really be like, oh, what actually is it?
It is a planet.
Nice.
Big ball of rock.
It's a tropical planet.
Very
Actually, yes.
tropical.
They used to think that.
I have a feeling we'll talk about that. I think we might talk about it. I don't
The
know.
All right,
humidity.
so some basic facts about it. It is 67 million miles away from the sun, which is 0.72 astronomical units, which is the average distance the Earth is from the sun, 93 million miles. 67 million miles is 108 million kilometers for everybody else in the world. It has a diameter of 7,521 miles, which is 12,104 kilometers. It's only 400 miles smaller than the Earth's diameter.
Yes. So it's known as
Earth's twin.
Earth's twin.
Yes.
Evil fraternal twin.
Yes, it is about the same size. It's about the same mass. Its internal structure is very similar.
And it's funny because on Liz's shirt, Venus looks slightly bigger than the Earth.
I guess it does a little bit. Here's the Venus.
Yeah.
And there's
you got to contact the publisher about that one.
I mean, it's very similar in size. Look at the little moon there.
I like the moon. Anyway, sorry, Mike.
Its day, well, the amount of time it takes to go around the sun once, so its year is 225 Earth days.
Okay, so a little shorter year, because obviously it's closer to the sun.
The amount of time it takes for it to spin once on its axis for the Earth, 24 hours long. For Venus, 243 Earth days. So its day is longer than its year.
Yeah, that's a long. God, that's a lot. Some of the Mondays feel like that, though.
Yeah.
Man.
So the time between the sun rising and setting, 117 Earth days.
I mean,
that's a long time.
Whew.
But the temperature is only roughly 850 to 900 degrees Fahrenheit.
Only.
That's not bad.
You know what that means?
It's doable.
You know what that means, everybody?
What does
I'm
that
waiting
mean?
for it.
You know what that means?
What does it mean?
That means you could cook a large pizza in 9 seconds.
In 9 seconds.
Bada boom. Yeah.
I was hoping you would do
It's called fast food right there.
it.
But you know why you should never cook a pizza or anything on Venus?
Why's that?
Because you're gonna cook yourself at the same time.
Yeah, that's true.
So it's
Okay.
Yeah, that's true.
jumping in the kiln with the pizza is not usually the outcome.
It has a tilt. Its tilt is only 3 degrees, though. The Earth's tilt is 23 degrees.
Oh, so not very exaggerated seasons then. Or
no seasons.
No seasons.
No seasons.
No seasons.
In fact, that temperature, we'll say 900 degrees, that's day or night.
It's just always hot.
It is always hot.
It's one hot bitch.
It's hot enough to melt lead. That's how hot it is.
Yeah.
So,
Yeah.
extremely hot.
Yeah, so, not an easy planet for exploration.
No.
At all.
No, and we're going to get into that.
Yeah.
It does go through phases. We'll talk a little bit more about that later on.
From our perspective.
From our perspective, yes, it does go through phases. And from going from a new phase to, quarter, full, third quarter, back to a new phase takes 584 days.
Damn.
Wow.
Venus days or Earth days?
Those are Earth days.
Earth days. Everything's in Earth days.
I know, but that'd be 500 years. That's fine.
Yeah.
That's just interesting how, Venus is what, 93 minus 67? What's that? Quickly, math, do it.
25.
So it's only 25 million miles closer to the sun than we are, and in the scheme of things, that's not really that big of a difference. Yet, and it's it's being similar in size and composition. It's such a drastically different planet from the Earth, and had drastically different things affect its evolution throughout the history of the solar system. That it's very interesting that you have something that could be very Earth-like, but is so diametrically not Earth-like.
Right, and yeah, so it's the big question is why.
Yeah.
We don't really know why, but we have some ideas. But we have spacecraft that have been looking into that question, and there's a spacecraft there right now that is meant to be looking into that question.
Is there?
But Mars? It's not Mars. Fucking Mars.
Fucking get out of here, Mars.
Venus has a very thick atmosphere. It's mainly carbon dioxide. 96.5% is carbon dioxide.
Okay, see, guys, look, if you got issues with climate change, look at fucking Venus and what a lot of carbon dioxide does to a planet.
No, because it's closer to the sun. That's why it's hot. Come on, Liz.
Oh,
it's science.
Yeah. Yeah.
3.5% is nitrogen.
Okay.
So the rest is just...
We got some nitrogen in there. Okay.
Stuff.
Just a death.
Very little.
Just...
it's mainly just carbon dioxide.
Suffocating. It's a suffocating
It's mostly just old blood in the atmosphere. Boiling old blood.
The clouds. The beautiful clouds of Venus. Sulfuric acid.
Yay! I love sulfuric acid, Rain. You know what? My hot toddy, I was going to add a few drops of sulfuric acid just to make it a little... realistic, add the Venusian element to it, but then I was like, "Oh, I don't want to die."
That's a good name for your second drink, sulfuric acid.
Okay, Gold Rush is now sulfuric acid, which alcohol is technically a poison. So
yeah, that's
right?
true. Too much of it, yes.
Yeah,
anything's a poison in large amounts.
That's true.
That atmosphere, though, that blanket of an atmosphere is quite heavy. Its mass is 92 times the Earth's atmosphere.
Wait, yeah, okay.
The mass
of the atmosphere is 92 times the mass of the Earth's atmosphere.
Right.
So yeah, it's like a extra weighted blanket.
Yes. But the pressure, what you feel, the weight of that atmosphere is 93 times the Earth's pressure, atmospheric pressure, which is the same as being 5/8 of a mile below the surface or of the ocean.
Of the ocean?
Yeah,
or
1 kilometer.
So, crushing. So not only do you just get burnt up to a crisp as if you've been breathed on by Smaug.
Oh my god.
But you get crushed to death as well.
That's
like atmospheric pressure.
That's like the same amount of pressure that dogs give you when you're putting on shoes. Like, it's a walk time. We gotta go.
Yeah,
so much pressure.
Yeah. Leia's
pressure.
reaction as soon as I put socks on, Leia's like, "Oh!"
That pressure is greater, actually. The atmosphere, the winds in the upper atmosphere is about 200 miles an hour.
Hello.
So hurricane force winds.
God,
However,
wind
at
PTSD
the surface,
would not do well.
they're only a few miles an hour. But there's an interesting fact about that. But before we get there, those winds, they are amazing at transferring heat from one part of the planet to another part of the planet. That is why the night side is the same temperature as the day side, because the winds will take it to the night side.
What causes the winds?
Now, that similar question to Liz that we don't expect Mike to know, but we're asking me all these things. So on Mars, they have lots of wind, but the atmosphere is so thin, you don't really feel it that much. But on Venus, there's so much air, when you
because
feel
of all
it
that
even
pressure,
more.
right?
Yeah.
It has a thicker atmosphere.
So the winds winds on Mars, 100 miles an hour, is like getting hit with a feather pillow. Okay, yeah. Like getting hit with a feather pillow. On Venus, it's only a few miles an hour at the surface, but just ignoring the heat, ignoring being able to stand up.
Okay.
Sure.
Ignoring everything else that could kill you.
That slow wind hits you with such force, it is extremely difficult to walk. You might not even be able to walk in it against the wind.
You know what? I do have one of the things I would love to try one day, which I would have the opportunity to do. I don't know where, but like get in front of those big like wind turbines or something that you use in like Hollywood or something to simulate and like try to power through.
Oh yeah, you can do that in Oklahoma. Just stand outside.
But I don't want to be in a hurricane. I don't want to be in a I want to be in a safe, controlled environment.
God, so I remember in Oklahoma, there were some days I literally had to lean into the wind just to get into the office building. Like, it was so difficult.
Wow.
Ugh.
Wow. So, yeah, as Katie says in chat, Venus be wild.
Venus be
Venus be
wild.
wild. Venus be thick. Venus be wild.
Venus gone wild. Venus gone wild.
So,
Remember those days?
Is that why Venus is so blurry in the pictures?
In the atmosphere, there's these like dark regions in the atmosphere.
Mm-hmm.
They're called blue absorbers.
Oh, like your drink.
Yeah, we don't know what's causing them, but they absorb a lot of the ultraviolet light. In fact, they absorb, it's something like half the heat, 2/3 the heat, the heat energy that the planet gets is absorbed in these blue absorbers. They don't know what they're made out of.
And it's in the atmosphere.
It's in the atmosphere.
Like, are they like pockets? Like, they're just like
they're
small
like
areas?
little streaks. I mean, you can see them.
Okay.
You can see
okay.
them. There are these dark
Are they the
streaks
areas
in the clouds.
pictures that do they look darker?
Yeah.
Okay.
Oh, that's them. Okay, yeah.
Yeah.
Okay.
And they're called blue absorbers, and they don't know what the hell they are.
We should call them blueies.
Blue. So they absorb ultraviolet light. There's some questions as to what they are. Is it like some sort of iron dust kind of thing? Is it life? There's actually we actually did,
but high up in the atmosphere, yes.
But high up in the atmosphere, we did a podcast talking about the life of Venus on Venus. So you can check that out. But I believe it had to do with this. But you know, as hot as Venus is, about 30 miles up, 50 kilometers, the temperatures drop to about 86 to 150 degrees Fahrenheit.
Oh!
That's completely reasonable.
Nice!
Yeah, and the pressure is similar to what we have on Earth's surface. So this could accommodate extremophiles.
Like water bears.
Or Phoenicians.
Or Phoenicians. Yeah, that's exactly the weather that any Phoenician is, or anybody that lives in, like, you know, near a desert. I mean,
you
like
can make yourself a real
is hot.
Yeah, make yourself a real fine cloud city up there.
Yeah, there you go.
Not a reference.
It is totally.
No, because it's just literally city in the cloud city. It's not the reference thing.
It's Cloud City.
It's not capitalized.
Knowing us,
not a proper noun.
Knowing us, it would be capitalized. Although the space law is.
All right. Venus has lightning. That is controversial, though.
It's controversial that it has lightning. Do we not have direct evidence, or
we don't have direct evidence?
We don't have direct.
You
evidence.
have indirect evidence that you can infer that there's lightning that caused it, but.
We haven't observed like these charged particles.
We haven't observed the flashes. You haven't observed the flashes.
They come in quick. They come in hot.
Come in hot.
There we go.
So, you know, there's some debate as to whether or not there's actual real lightning in Venus.
I mean, most of the planets that have thick atmospheres seem to have lightning.
Well, yeah, it's just kind of that friction going on there. Yeah, cause it static.
We've observed it with Jupiter and Saturn. I mean, there's aurora on Jupiter and Saturn as well.
Yeah.
I mean, does Venus? I don't know if you're going to mention that. Oh, okay. I won't say anything. All right, you know where I'm going.
Talk about magnetic sphere.
It's a magnetic field. Yeah.
If you were actually on the surface, ignoring whether you could actually do that,
all death properties,
it would be similar to an overcast day on Earth.
It's not bad. Those are my favorite days.
But you would like never see the sun.
No.
And the color would be different than the overcast day.
Yeah.
So later on, we're going to talk about Venus and science fiction and stuff. And there's a short story that I read when I was in school about Venus, like elementary school.
Oh.
And it was so sad.
Oh.
And so, but I will get into that later.
Because maybe I know it.
Oh well. Okay, yeah. So,
I read a sad story.
Very thick atmosphere.
Mm-hmm.
Up underneath that atmosphere is terrain. Land.
Well, it is a rocky world. It's a terrestrial planet. It does have a surface, unlike the gas giants that do not have a surface.
The features on that terrain are named for women, real and mythological. There's only 3
real women.
Not.
Oh, wait. Say that again.
Real women. Mythological women.
Mythological women and real women.
Yes, named for real women and mythological women. Except for 3 objects that are not.
Oh, okay.
They go by the name of Alpha and Beta, which we'll talk about later.
Okay.
And Maxwell Montez, which is the tallest mountain on there, named for Maxwell, the physicist.
Right. So the tallest mountain on the planet. The tallest mountain, still.
Well, you know what? Long
live
live patriarchy.
Jesus. God, kid.
Well, it was one of the first things that was discovered, and
naturally, then it's got it's the tallest thing. It's got the biggest dick. Let's name it after a dude.
But it does have some pretty large features on it. Ishtar Terra, which is an Australia-sized highland, which is at the North Pole. Aphrodite Terra, which is a South America-sized region, which is at the equator. So these are very large. The surface is also very young.
Yes.
So, how do we know that? When we look at the surface of Mars, and we'll get into how we do that, we don't see many craters at all. In fact, I think maybe only the Earth has fewer craters than Venus does. Owing to the fact 3/4 of the Earth is ocean. Yeah. But also, we got a lot of weathering that takes care of things as well.
Yes.
But we don't see a lot of craters, which is indicative of a younger surface. And the thought is that the surface is only 150 million years old. And that is very young. And and that young surface is due to volcanoes and tectonic surfaces. And Venus resurfaces itself every 250 to 300 million years.
Wow.
That's how much.
So it still has, if being similar in size of the Earth, I would assume then that it still has a churning molten, its core isn't cooled down all the way because we have a churning molten core. Right. Still, it hasn't cooled. So then there is volcanism then that is still occurring to then resurface that planet. And tectonic activity, do we know if it has like plates like we do?
Well, tectonic forces. I don't think that necessarily means
just like
volcanism. I don't believe it has plates. Plates are a whole another topic, which are fun to talk about.
Okay, because I've never heard of any other planet, a terrestrial planet, having plates like the Earth does.
And the history, the theories behind tectonic plates are really fascinating too. But that's not a right now topic.
Okay, that could be a hangover topic to
So, 150 million years ago, when it started getting resurfaced...
Yes, hold on. What was going on the Earth 150 million years ago?
I was about ready to give you that. Dinosaurs.
Dinosaurs. Okay, that's what I thought. That's what I was... All right, so in the dinosaurs...
I heard the whistle.
Was that the whistle? I heard a slight little...
Yeah, that was a little whistle, not the big whistle, a little one.
A little whistle. All right, so take a drink.
They have 3 types of whistles. Anyway,
Venus has mountains and valleys and a shit ton of volcanoes. Resurface the whole surface. The highest mountain, Maxwell Montez, is as tall as Everest.
Wow.
Wow.
It's really interesting because, and I know you're going to talk about like spacecrafts that have landed and our imaging, right, of Venus. But it's so hard to get the sense of scale when looking at images of Venus. When we're looking at the radar images of the surface, we'll explain that later. But like you don't get a sense of like the relief and the scale of the surface features.
And that's why I love like the one picture we have of the surface so much.
Yeah.
The surface features obviously are, the valleys and the volcanoes and stuff. They have things they call pancakes.
Yes. Yes.
Which have flat tops, steep sides, and are formed by highly viscous lava.
There's a smiley face. There's a smiley face.
Oh, yeah, that's right.
There's a smiley face pancake. You just Google smiley face on Venus, and I'm sure it'll come up.
And another reason why these things are pancake shaped is because of the weight of the atmosphere. So it's not like you can have these explosive events. You can. A volcano could go boom, but that lava doesn't go far because the weight of the atmosphere
is flattening it into a pancake. How does
I wonder,
mountain as tall as Everest then?
Lots of time building up in a single location with no plate tectonics.
It's like layers.
All right. Yes, that makes sense. Okay, thank you. What were you going to say, Brandon?
I was curious how ejecta operates with the high pressure on Venus, because here on Earth or even Mars, the ejecta can fly out around the other side of the planet. The impact's big enough. But on Venus, I imagine the impact will be slightly different with the ejecta being flung out from the impact.
Well, Newton's laws are still Newton's laws.
Yeah.
And so when you shoot something, it is the simplest case is to ignore air resistance, right? And they do try to make bullets and shit to where aerodynamic to where you can really minimize that. However, though, you do have to take into air resistance. And ejecta from volcanoes is not exactly aerodynamic. And so it has a larger cross section than, say, a bullet would. And it's going to experience more air resistance. And so it's not going to go as far. So to get an ejecta to go all the way across Venus to the other side of the planet, that is a forceful explosion.
What?
God, I'm not going to make it through this.
That makes me wonder what, and I don't want this to happen or
Did I answer your question, Brandon?
Well, I was talking more about ejecta from impacts, but volcanism, same principle.
It's the same, yeah. But I wonder what nuclear weapons are not great. We don't like them, but I mean the mushroom cloud is beautiful in a perspective. But I wonder then what the difference of the mushroom, a nuclear weapon explosion, would look like on Venus.
It would be like a portobello mushroom.
Okay.
I mean, all right. So the initial blast is going to thin out the atmosphere a bit, but the atmosphere is going to come back in,
and then the wind's going to clear a lot of that out too pretty quickly, I'd imagine.
Right. So when you see,
you can do it.
Man, so when you see a nuclear blast, they have.
Hopefully you don't.
Yeah, so they have video, and it's usually this house, and it's got the trees that are near it.
Yeah, the lights.
And you see the trees, the trees go this way to, let's stick to the right, it doesn't matter. And then almost immediately, and the house blows to the right as well, and almost immediately the trees go back to the left, and the house blows back to the left. That is the air pushing through and then going, I don't like a vacuum, boom, and it pushes back. And so, whereas the blast is going to thin out the atmosphere, it's going to quickly kind of return. Your cloud is going to be, cloud's going to be flat.
Well, weirdly, this would be a good visualization. So in the movie Pacific Rim, they detonate the nuclear warhead underwater, and it clears all the water out, and then the water rushes back in. So it's the same thing.
It's the same thing.
Yeah. All right.
Thanks, Guillermo del Toro.
There are these features called ticks which are odd volcanoes with veins
Okay.
that resemble the little bloodsuckers.
Yeah.
Less Lyme disease though, but
Yes.
still more death.
All right, so tesserae.
Okay.
These are grooves and ridges that suggest, quote, scorching temperatures make rock behave in such ways, in some ways more like peanut butter beneath a thin and strong chocolate layer of on Venus.
Oh,
Okay. Where is that
alright.
quote from?
NASA.
Yes. Hell yeah.
Making
It's from
Venus delicious. Peanut butter beneath a strong chocolate layer.
I know, right?
And when you get the magma, the lava out there, then you can add some strawberry to it.
Hey, yeah.
Ooh, yeah.
All right, so
With
you
your
brought
pizza?
up magnetic field.
Yes.
You're talking about aurora. Venus doesn't have aurora. Unfortunately, that'd be cool.
It's just that its atmosphere is too.
Well,
You don't see it.
it doesn't really have. All right, so it doesn't have an internally generated magnetic field.
Oh, so it doesn't have a churning core or
Yeah,
a churning layer outside the
because
core.
it spins so slowly.
Yeah.
The core doesn't churn like the Earth's, and so it doesn't. Now, it does have a magnetic field, though. That magnetic field, though, is not from its own making. It's from the sun.
This is still close, yeah.
Yeah, so, well,
Oh,
sort of.
What?
Well,
Sort
I mean,
of.
yeah.
Okay.
So, the sun has... All right, Venus in its atmosphere, like the Earth, has a region where the ultraviolet radiation basically strips off a bunch of electrons, and you have all these little ions. It's called the ionosphere.
Mm-hmm.
Venus has that as well.
Okay.
And so so it has this magnetic field. It has this ionosphere with all these little charged particles, ions, stuff. Streaming past Venus is the ever-present solar wind, which is a bunch of charged particles. These charged particles kind of carry the sun's magnetic field with it a little bit, and the interactions between that solar wind and the ionosphere induces a magnetic field around Venus. It's a very thin and not very strong magnetic field, but it is there.
Okay.
And it's not really going to make aurora. It probably would make a few, but you're not going to see it.
Right.
And it's that induced magnetic field is shaped also by the solar wind. So the solar wind induces it, makes it for Venus, but it also shapes it into a teardrop shape.
Neat.
Okay.
And so,
Oh, interesting.
yeah. So Venus, because it spins so slowly, doesn't really make its own magnetic field.
Okay.
Even though it might have a...
Now, it spins slowly because it's spinning backwards, right?
Oh,
like
shit,
it
we
got-
didn't talk about that.
Yeah,
Well,
it
yeah,
got-
we will. I mean,
Oh,
we kinda
okay.
will, but-
It possibly got hit by something, suffered a large impact, you
Right.
know, in the early days of the solar system, and that
Well-
fucked its spin up.
Okay,
'Cause
well...
it spins backwards, so that slowed it down, so it can't.
Well, there's
Maybe.
Mike, go.
Okay.
So, here's the main thought. So, let's take a look at the Earth.
Yes.
Let's-
Look at it. Everybody look at it. Close your eyes. Visualize the planet Earth.
Or just look down.
So, the Earth is slowly slowing down.
Yes.
We have to have this leap second every once in a
Yeah, we got a
while.
lot of drag from the moon there.
Right.
Close
So, the moon pulls the oceans, creates those
What?
tides.
Tides? How do they work?
We don't know. It's God.
It's a
Tides
series of
go in,
tubes.
tides go out.
It's like magnets. We don't know.
That's our second Bill O'Reilly reference today.
Is
I
it?
think
Oh, right. Yes.
Brandon had one before the podcast. Anyway, so the Earth's spinning fast enough to where the Earth can pull those tides in front of the moon. So the moon pulls on the tides, and it makes it kind of act like a brake, and it slows us down a little bit.
Yeah.
So
Friction.
What?
Friction.
Yeah, friction. Let's go to Venus.
Okay.
Okay.
Venus has a very thick atmosphere. That atmosphere, like the tides, serves as friction with Venus spinning beneath it. And so they think that the atmosphere played a significant role in slowing it down. Not so much from an impact, but from the atmosphere.
And that
It's also closer to the sun.
And
so
That atmosphere, though, being thick and formed from the just enormous amount of volcanism that it had in the early days of the solar system.
Yeah.
It.
And isn't it not just spinning back, but isn't the entire planet upside down?
It is. We'll get into that.
Yeah.
We'll get into it.
We'll get into it, people.
So
stick with us.
Let's talk about observations. Now I gotta be quick. Gotta go fast.
Why?
Because
We're on Venus time here. Time doesn't matter on Venus.
that's true.
Unless you just can't talk because you're going to start coughing very
Oh
soon.
my gosh. It's probably the latter. Anyway, we can see Venus with our own two eyes, but the first time we saw it through a telescope was in 1610. Galileo Galilei saw it with a telescope. He noticed it went through phases, and those phases were in such a way that Venus had to go around the sun and not the Earth.
So it was closer to the sun than the Earth, which means that Copernicus was right. Ha-ha!
Right, but it got him into a little bit of trouble.
Well, yeah, the church doesn't like to fuck.
Well, he was also an asshole about it, but we have a whole Galileo episode.
I mean, but he should be an asshole about it. But yeah, we do. Check out our Galileo episode.
30 years later, roughly, December 4th, 1639, transit of Venus. Jeremiah Horrocks predicted the transit, and it came true. And he and a buddy, William Crabtree, went out and observed it.
The transit of Venus, by the way, just when we observe Venus passing in front of the sun, and so we can see it's a transit.
Could you imagine, like, we're hanging out together and we have this idea, hey, what if Venus transit the sun? And, like, us and our buddies here, we just go and observe it and just make history because we're sitting on the couch thinking about it.
I know, right?
That'd be really cool.
Oh, man.
Like, it was interesting the days where you can just kind of do that and make history.
I know, right?
They were English, I believe. Johann Bach? Myself. 1761, Mikhail Lomonosov. Russia.
Mexican.
Discovered Venus's atmosphere. So it's the first time that we discovered its atmosphere. Johann Schroeder, who was German in 1790, also observed the atmosphere, as well as Chester Smith Lyman. In physics, you have things called Lyman lines.
Any relation to Josh?
What?
I don't know who Josh Lyman is.
It's a solid reference. Anyway, keep going.
Giovanni Cassini calculated Saturn's rotation to be 24 hours. He was wrong.
He was, Cassini.
He was only wrong by 500 days or something.
Yeah, well, 243 days, yeah.
I mean, it's a long rotation. I mean, who's going to guess
off
that?
by a factor of 243.
Yeah, no.
Nothing more of note until the 20th century, basically.
Oh, really? Nothing more on Venus of note.
Right.
Until the 1900s.
Right.
We go from, I'm sorry, what was that last date? The 1700s.
Because
end of the 1700s until the 1900s.
Because if you think about it, we only had optical telescopes until the 1900s. So that's all we could see it with.
That's true, and you can't see through the thick atmosphere of Venus. You can't really...
It's still funny to think 200 years. Yeah, it's there.
Yeah.
We know most things about it. And even in the 1900s to 1950s, as Mike will get into, we still
Early 1900s, Vesto Slifer.
I love that name.
We've talked about Vesto before, and that's just a cool ass fucking name, like Rip Torn.
Yeah, associated with.
It's the coolest name ever is Rip Torn.
What's the observatory? Lowell Observatory. Associated with the Lowell Observatory.
Good old Lowell.
Yeah, he was there.
Up in Flagstaff.
He was up in.
Check it out.
Anyway, he tried to measure the rotation of Venus using Doppler, and couldn't do it. So he surmised it must have a much slower rotation than previously thought.
Which it does.
Nice.
Well done, too slow for Doppler.
Yep. Frank Ross, 1920.
American?
I believe so.
Sounds American. It just sounds like an American name.
I'm an American.
It's not a fancy name.
It's what's the word I want to use? Give me my jet lag brain a second. It is unimaginative.
Yeah, okay.
First ultraviolet images, and it showed a lot more detail than visible and infrared images.
Okay. Well, that sulfuric acid reflects a lot of ultraviolet light.
Yeah. fast forward to the 1950s is when we first
It's like you got fairies in
discovered
the
that the rotation was retrograde.
Hey, we're like, wait a minute.
Retrograde.
This shit is going
rotating
backwards. This is weird.
So,
Unconventional, just like women.
So,
I don't know.
yeah, well done. Everything should be rotating the same direction.
Yeah, because
so
the
when you
solar
find
nebula
something,
was rotating one way, so everything that formed within it is rotating in that same way, unless acted upon by an outside force.
right? So,
Liz just made a new dance.
This is the solar nebula dance.
all right. See now, all right. When we discover something that's rotating backwards,
We
then
go,
it
Shit
so
went down.
the question is, did it form with everything else rotating backwards and violate every law of physics that we know?
I mean, it's
Really,
possible.
really, it's just one, conservation of angular momentum, but whatever.
It's a big one. That's a big one, though.
It's kind of a
Or did something happen?
something happened. Something
to it.
happened. It's Occam's razor. Something fucking happened.
Yeah. The simplest explanation is that Venus was hit and tipped it over on its side.
I mean, most things in the
upside
solar
down.
system have been hit by shit because the early solar system was a very chaotic place with a lot of shit flying around.
Uranus.
Yeah.
So I do want to point out, though, that you do not have to have a direct hit. You can have what's called a gravitational collision, which is an object that gets close enough to it where it just the interaction just flips it, which is a bad day for anybody on. It's a bad day no matter what. So, you know, it's
And
yeah.
quick little tangent. There is a theory that's been thoroughly debunked, but there's a theory in the early 1900s that a lot of the gas giants actually flung off from the sun. So Jupiter, Saturn, Neptune flung out from the sun because it made of gas. So as it flung out, they would pass like Venus, and the gravity would completely flip it on its side, and that was one of the points behind this theory. Completely wrong.
Yeah,
Still.
because then that would happen to all the planets, right?
Well, just the one that passes.
And also
by
the
with
sun
close
is
to the
primarily its outer surface is surface. I say not as a surface, but it's plasma, not gas. So, you know.
Like we said, it's a very wrong theory.
Yeah, but it's interesting. It's interesting.
Yeah. Theory through
So
the
in
50s.
the 1950s,
The 50s were a fun
and prior to the 1950s, Venus was thought of as a tropical paradise.
Tropical.
This is my favorite time in Venusian history. Is the 1950s.
When Venus was just
So-
like a Hawaii on steroids.
Yeah, I mean they thought it's a little closer to the sun, so
It's a little hotter.
it's just a little warmer.
Yeah, a little balmy. The thick atmosphere
Bring
keeps in the humidity, so it's
Bring
going to
your
be like Hawaii.
Hawaiian shirts.
Yeah, it's
Bring
about
your
the same
tiki
size as the
luau's.
Earth, so
Yeah.
clearly it probably has oceans.
So,
And
and
the same
this,
mass as the Earth as well.
Grab the Beach
so
Boys.
it was favored over Mars to harbor life at this point in 1950s. Like I thought for
yes.
sure there'd be life out there on Venus.
I mean,
That's-
it makes sense.
And when we get into Venus and sci-fi,
Hell yeah!
you're going to see a definite turn.
It's a slow
thinking
turn because it's Venus.
I mean, it really is very All right, so we're like, hey, we have the technology. Let's send shit there.
Yeah.
And
Fuck yeah!
the Soviet
Don't poke it.
Union, now known as Russia, in 1961, sent Venera 1, which is just a venereal disease to me. It was the first
Venereal. Obviously that has its. Okay. All right.
It is the first
I'll look up the
interplanetary
etymology
space
there.
flight, but we lost contact with it, and we, the Russians, lost contact with it en route.
I love the mirroring between Venus and Mars as far as space probes go out there because the USSR really focused on Venus, whereas the United States really focused on Mars, and we had similar successes and failures on both of them.
Well, space is hard, as we say.
Yeah, makes me happy.
We get in the act in 1962, December 14th, with a flyby of Mariner 2. It went 21,600 miles, which is 34,800 kilometers above the surface,
It's
and
close.
it made measurements of the atmosphere.
Yeah. That's all I could see is the atmosphere.
Venera 3, 1966, crash landed on Venus and returned no data.
Yeah, because it crashed.
Venera 4,
Hold on.
Soviet Union, 1967, deployed science experiments in the atmosphere, before crashing onto the surface. But it found the temperature was hotter than Mariner 2 observed, and the atmospheric density at the surface was far greater than expected.
Boys. Oh, shit.
No more balmy temperatures.
Yeah.
No, not a tropical paradise.
In one of the first examples of sharing data, the Venera 4 and Mariner 5 data were combined
Sharing
and studied
data between the Soviet Union and
the
U.S. We
And-
can all get along, everybody. See?
And over the next year, they did various science talks and science talks.
Colloquials.
Yeah, those.
Colloquial. There's
Anyway.
a word.
All right, whatever.
We have brains.
Venera 7, Soviet
This is the
Union,
one.
December 15th, 1970, first soft landing on another
Oh
planet.
my god.
Hell yeah.
Oh my. Okay, everybody out there, because
So-
this is a podcast, and I'm too lazy for the video edition. If you're watching this on YouTube, to put the pictures in, Google Venera 7 Venus images. Holy shit! Like these are images on Venus's surface.
And then I don't know what Mike's going to talk about, so I'll let him finish his topic, and then
Yeah.
I will jump in if he doesn't mention it.
Okay.
All right. Like I said, it was the first soft landing on another planet. I'm
not there yet. Okay, don't Google Venera 7.
It sent data back to the Soviet Union for 53 minutes. 20 minutes of that 53 minutes was on the surface.
It's just the robot screaming in pain.
Yes, and it found the temperature of 887 degrees Fahrenheit, a pressure of 1,320 pounds per square inch.
Now remember.
Yes.
Okay, so Venus is very hot. The technologies that we have for these spacecrafts is they're made of metal that can melt in hot temperatures.
Yes.
So basically,
Correct.
the spacecrafts melted.
Yeah, very much.
And they could not. They melted on the
components
surface.
melt.
It's the opposite of Mars.
Well,
They
I imagine
melted.
the spacecraft itself probably lasted longer than the silicon chips inside. I'd
Well,
assume.
yeah. The imaging
I actually don't know the melting point of
technologies.
silicon, but I assume it's less
But
than.
okay, so
metal.
the next one, I got too
Good
excited.
question.
I got too ahead of myself. The next one is what you want to Google for the images.
Arecibo?
No, Venera 9.
Okay,
Oh.
but that is not the next one.
Okay, I missed that
All
bullet
right.
point.
So,
Oh, Jesus Christ! Sorry.
the
The melting point of silicon is really high.
Okay,
Ignore me.
So it's not the silicone melting.
All right, so Arecibo,
Woo!
late 70s.
This is why Cosmos with Cosmos.
Arecibo, rest in peace, was a large radar radio dish in Puerto Rico.
Oh, the same
Yeah.
Arecibo.
Yes.
Oh God, it hurts.
It was the first used radar to see the surface, saw two highly reflective regions called Alpha and Beta. That's where those
Of
names came
course.
from. And also saw Maxwell Montez, which had already been named at that point. Venera 9 and 10, 1975.
Here it
First
is.
black and white images
Yes,
from the
here it is.
surface.
Okay. Google these images because it's amazing. But like you look at these images and it looks like it could be from Earth. Like the rocks
Yep,
and everything,
yep.
they look like they could still be from Earth. And what's interesting though is that also Google Huygens.
That's the land of the
Huygens.
Huygens.
It landed on Titan, the largest moon of Saturn, and it's a dried up riverbed, and you see pebbles that you could find in a dried up riverbed on Earth.
But these pebbles, you're talking about
Huygens, yeah, Titan.
made of ice.
Made of ice, yes.
Which are harder than steel.
Yes, but the images from Venus, I don't know, because it looks so terrestrial, it looks so familiar, but then you look at it and you think, okay, these are images from a different planet, these are images from Venus, and it's mind-blowing.
Right.
And it's amazing, and I wish my in-person eyeballs could see them in person without dying.
I absolutely love these images. You can see the same thing on kind of on Mars, and you see how Earth-like those can be. But one of my favorite things, and Liz, Mike, and myself, and really any person you see on TV, would do this. When they get very excited about describing something, they kind of lean forward a little bit and back. They rock slightly. It's true, and that's exactly what Liz just did.
It's just, yeah.
That's how you know we're excited. Is we lean forward, but then we also try to rock our whole bodies.
It's just a weird human thing.
So
for all the aliens that are watching or listening to our podcast, this is just what humans do. I'm sorry if it's weird.
All right, so for aliens psychology thing, they can do later. All right, Pioneer, U.S. Pioneer Venus Project. 1978 to 1992, 2 probes, Pioneer multi-probe, Pioneer Venus.
Can I cut in? We haven't had anything land on the surface of Venus since Venera.
I will tell you.
All right.
It's complicated.
Okay, Venera 13 and 14, 1982, also Soviet. First color images of the surface. Okay, that was...
Mike hates us so much right now.
Now, before the show, I was like, hey, remember, we're going to be interjecting, and we got things and jokes and whatever. You got to just... we have to have a conversation.
I haven't had a conversation.
No, you can't get annoyed by us.
Every episode that Mike leads, we interject on him constantly.
I have given you so much time.
Take a drink every time you feel like Mike's annoyed by us.
15 and 16. Also Soviet Union, 1983-1984. Mapped 25% of the surface. Ooh. The last of the Venera missions.
Oh, man.
All right. But the Soviet Union was not done. 1985, the Vega missions occurred.
I arrived, I conquered, I'm here. I'm here now.
Vega 1 and Vega 2, the last entry missions for Venus, where they go down to the surface. These actually were the first to deploy flying craft on another planet. They deployed inflatable balloons.
Before Mars?
Before Mars.
Before the bouncy balls of Spirit and Opportunity? Were they bouncy balls, or were they just like...
No, these were balloons that went in the atmosphere.
Okay, not the bouncy balls. Okay,
no,
they were just like balloons.
This was before the helicopter.
Okay, they were just like, let's put some balloons in.
Yeah.
Wait, do you know how long the balloons lasted?
He's about to get into it. I thought he was.
I didn't know. I don't know.
I mean, I can't imagine they would last long with the pressure and temperature.
The U.S. is not done now.
Oh, no, we're never done. Have you met us?
1990 to 1994, the Magellan spacecraft.
Radar imaging?
Yeah, so the Magellan spacecraft, this mission was to map the surface and measure the gravitational field.
Oh, my God.
It was a mission of first. It was the first spacecraft launched from the space shuttle.
Oh, I didn't know this.
Yes, it was also the first to use the inertial upper stage booster, which is a two-stage solid fuel launch system developed by Boeing.
Oh, remember when Boeing cared more about profits?
Didn't care about profits. Yeah, so I mean, it's a whole thing. Don't worry about it.
Yeah. No, we watched the John Oliver on
Anyway,
you should. And
I know about it.
Yeah.
Magellan was the first also to test aerobraking as a means to circularize.
God, I love aerobraking so much.
Okay, now Magellan was the first to get radar imaging, right?
Well, right. Yeah, that was his whole mission.
I also feel Mike wants to talk about aerobraking because it's really fucking cool.
Well, yeah, so I mean, it's all right.
You talk about aerobraking, and then I'm gonna get excited about radar imaging.
Okay.
Go.
All right, so you have a spacecraft. Spacecraft has to leave the Earth to go where the fuck it's going.
Yes. Step 1, leave the Earth.
Yes. Which means you gotta build up a lot of speed.
Yes. Reach escape velocity.
Coming in hot.
Yeah. So
you're out hot.
So you're going out hot, but when you get to Venus, in this particular case, you're coming in hot.
Yeah.
You gotta slow down.
Right.
So how do you do that? Well, there's you can take propellant with you and use that to burn rocket fuel
in the opposite direction.
In the opposite direction that you're going, it will slow you down. You do it for a certain amount of time. It's usually multiple burns, probably not just one burn.
Lots of math involved.
But it will put you in a circular orbit.
Okay.
Or what you could do is utilize the planet itself. Venus is a very thick atmosphere.
Is this
So,
like Fast and the Furious?
You
Tokyo
come in.
Drift?
You come in at a certain angle,
Okay.
and you hit the atmosphere.
Uh-huh.
Has to be a certain angle.
And then you slide around.
Well, what it does is the atmosphere it slows you down. That friction, as you're going through the atmosphere, you're hitting all the atmospheric particles, right? It slows you down. It causes friction. Slows you down. You lose speed, and you end up in a circular. Eventually, end up in a circular orbit.
It's like you're drifting around.
Now, long time listeners of the show will know in the first few episodes, Mike and I would constantly reference Red Mars to the point where Liz would make a drink game out of it. And Mike and I are both rereading Red Mars.
Yes, we are.
So, when the Ares, the giant ship they used to get to Mars, gets there, they slow down by aerobraking.
It's called doing your research as an author.
And it's within like 1,000th of a degree, so it has to be very precise.
Yeah,
it's not like you get close enough and we're going to use this to slow down. No, if you're too close, you will plummet to your death. If you're too far off again, you'll skip off the atmosphere like they were afraid Apollo 13 did.
Yes.
So it's a precise.
It's a very precise operation.
Okay.
Precise.
Now,
Magellan was the first to do it.
And Magellan also was the first to get radar images of the surface of Venus. So using radar, so like think of sonar, where you have basically you're sending a signal down that bounces off the surface, and the amount of time it takes to get back, you can then see the elevations and everything of the surface. So when you see pictures of Venus and you see them and they're like kind of like a yellow orangey color, and you're seeing all these features, those are the radar images of Venus's surface.
And they're also false color.
They're a false color. They're not obviously the actual color that we would see with our eyes. Whereas there are pictures of Venus that just show the atmosphere and the cloud tops and everything like that. But when you're seeing, you can see the pancake structures, and you can see these kind of like lava flow lines and everything that's on the surface. The smiley face on Venus, that is from radar imaging. So using radar to see what the surface, pierce the clouds, so look through the clouds, because otherwise we cannot see through the clouds, the atmosphere of Venus. We cannot visually with our eyeballs see the surface of Venus. We need special technology in order to see what the surface actually looks like. And so far we do not have the technology, or haven't developed the technology, or haven't used the technology to have a spacecraft that is able to withstand the high temperatures and pressures that are on the surface of Venus. So this is our method of being able to study the surface, is by using radar technology. And these pictures of Venus through radar imaging is, to me, like my favorite thing about looking at Venus. They're fantastic to be able to see these features that we normally wouldn't be able to see.
Right. Right.
Yes.
At large global features.
Hi.
And that's where we're seeing globally not a lot of craters. This must be
and
a
we can see
surface.
the resurfacing. We can see like these like lava flows. In fact, I think it was recently that it was like, there's been recent lava flows, which indicates that Venus somewhat has still an active core.
I feel like that was the last 3 years. It was probably the last 6 years. But I remember hearing about
recent.
that.
Yeah,
it's very recent that we're like, Venus still has some volcanic
anything
activity.
within like 6 million years. That's super recent.
Yeah, true. True.
Yeah, I mean, it really is. Just Magellan really kind of changed like how we.
Is Venus the closest planet to us?
Yeah. Yes and no.
Well, depending on where we are in our orbits.
Yes.
When it is at its closest,
yes,
it is. 30 million miles, whatever. But Mercury actually spends more time closer to us than Venus does.
Really?
Yeah.
Because it zips around real fast, so we're closer to it more often, I assume.
And so Venus is...
shit.
Yeah.
Okay. All right.
Unless you technically want to count the moon as a planet, which some do, but
No, the moon's not a planet. It's a satellite, because it's not orbiting the sun directly. It's orbiting the Earth, which is orbiting the sun directly. So therefore, the moon is a satellite.
I just really wanted to see that reaction.
There have been other flybys of Venus. Galileo on its way to Jupiter in 1990.
I didn't know he could get out there.
What?
Nothing else.
Cassini, on its way to Saturn in 1998 and 1999, flew past Venus. Messenger spacecraft in 2006 and 2007 on its way to Mercury.
Yeah.
Flew past
Mercury,
Venus.
I think, is the most underrated planet in the solar system.
I disagree, but I appreciate the sentiment.
Okay.
All right, Icarus, which is a solar sail mission, flew past
So it was-
Venus in 2010.
Importantly to note, not the spacecraft that was sent in the sunshine to restart the sun after it ran out of fuel. Different Icarus.
Yeah, because that's not gonna happen.
Yeah, but great 3/4 movie. Fantastic score.
All right, so European Space Agency got involved in
Of course they
2006
did.
with the Venus Express.
Hell yeah, choo-choo, motherfuckers.
I like that. Just a Phoenix Express, like.
I'm sure it stands for something.
This is a mission that was sent to try to learn in why Venus and Earth diverged in their evolution.
It's like you and Katie in your teenage years. They're so similar, but why
how
did they
we
diverge?
diverged.
Right, but then they came back at the end.
Then we did come back at the
So,
end. We
but
did.
all right. So if you look at Venus, Venus is about the size of the Earth. Also has about the same mass as the Earth. In its early days, most likely had oceans.
It could have, yeah. It could have been very similar to the Earth in its early days, and then rampant volcanism fucked it up.
Yes, rampant volcanism. Also, the sun, the sun got a little bit. Okay.
Vulcan, yes.
The sun got a little bit hotter, and so does more energy. The volcanism.
I mean, even though Venus is only 20 whatever we said before, 20 odd million miles closer to the sun than we are. Actually, even though it's a small distance in universe scale, I mean it's a pretty good distance in temperature difference between the sun.
Right, but not really. Also,
okay.
So I mean, it shouldn't
said.
be. It should not be anywhere near as hot as it is. It's definitely going to be warmer than the Earth.
Right.
It's not going to be obviously as hot as Mercury because it's 3 times that distance.
Right. It's just that buildup of carbon dioxide in the atmosphere.
So, I mean, if you look at it, all right, Venus is twice the distance from Mercury is from the sun. It receives 1/4 the sunlight that Mercury receives. If Venus had no atmosphere and Mercury is 800 degrees, that means that Venus would be about 200 degrees or so.
Like the moon.
Roughly, yes.
Okay.
A little warmer than the moon. But that's just rough friggin' ballpark right there. But it's much hotter than that. And so
the atmosphere.
How did it get so hot? So the volcanism, which you've already alluded to, the volcanoes just popping off all over the place, filling the atmosphere with carbon dioxide, makes that make any oceans that were there just evaporate.
Yeah, which then a runaway greenhouse effect is what happens. It's a runaway greenhouse.
The water vapor is also a greenhouse gas, but it starts to leach out into space, and you're left with nothing but carbon dioxide, a little bit of nitrogen, and just smattering of everything else.
Whereas Mars went through a runaway refrigerator effect because of such thin atmosphere, it couldn't hold that heat in.
Right.
I just think a brave little toaster with all these runaway refrigerators.
The brave little toaster. Oh, God.
So the Venus Express, Venus Express, it was to try to find out why
this shit happened.
Why this shit happened?
What the fuck went on?
But also, it had another mission.
Which
was
there was another.
Was it keep it secret?
Home. What?
No, come on.
This other mission was to look back at Earth.
So from Venus?
Yes. When it would look at Earth, the Earth would be about 1 pixel in size, which is about how big an exoplanet might be when you take a picture of it. So its job was to look at Earth and look for signs of life and you could use that to develop methods to find habitability or exoplanets.
Oh.
And importantly, they did not look for signs for intelligent life because they would find none.
Exactly. So it gave us an unprecedented study of the atmosphere. Its mission, end of mission was in 2014, deorbited in January 2015. So it burned up.
It burned
It's
up
now part of Venus.
in the Venusian atmosphere.
Yes. The only current mission at Venus right now is the Akatsuki mission.
Akatsuki. It's actually Akatsuki is from well, I don't know the meaning, but in the anime Naruto, Akatsuki is in there.
Okay.
So just
You know what? I will drink to that.
okay.
All right. So it's Japanese.
Akatsuki.
It's a mission to study the atmosphere. It got there on December 7th, 2015, which is a date in history. It's kind of a small little probe. It's only 5 feet by 3.5 feet by 5 feet.
Oh, so it's
Kind of small.
it's kind of all right.
It's about
I'm
your height.
5'3",
It's
so
about your height. No, you're 4'5".
I am 5'3" and a half, sir, and a
Thank you
half,
very much.
sir. Uh-oh.
That's a fit.
Uh-oh.
Take a drink.
Uh-oh. That was a coughing fit. We'll
Was
count
it?
that.
Oh, okay.
All right.
Honestly, after a coughing fit, you should take a drink.
I'm officially out of drink, so I'm gonna stab my
Yeah.
cherry with my cinnamon stick
Okay.
and make a little.
So it's the only one that's there. What I'm going to do is I'm going to save Venus and Sci-Fi
What is-
for The Hangover.
I just wrote that down in my notes
Okay.
for the
Okay.
hangover.
I want to know what a Polish donut is. Apparently, from
Okay.
Elizabeth.
We can find that out in The
Alright.
Hangover as
Alright.
well. So where can you find Venus right now?
Mhm.
For
Sky.
tonight, probably tonight only. It's in Capricorn. So-
Nothing to do with your life.
By the time you hear this, it will have moved out. But right now it's in Capricorn. It's very low,
Yeah.
very low in the southeastern part of the sky. So you basically need to be in Iowa to be able to see it where you have
Where
good
you
horizons.
don't have anything on your horizon.
Yeah.
This is a flat.
Yeah, and
Earth.
this is it's low on the southeastern horizon, so that means right before the sun rises.
So get up early, folks. If you got a clear horizon, just
Yeah.
see Venus. But throughout the year, if you notice something that is lower on the horizon before sunrise or after sunset, then there's a good chance that is Venus that you are looking at.
All right. Well, we're gonna save Venus in literature for later,
And
and
sci-fi.
Hell yeah.
sci-fi
Hell yeah, we
for
will.
The Hangover.
Yeah, I mean, there's a lot of just the human imagination to anything in space is always exciting. But Venus,
Yes.
of course, being Earth's twin and closest to the sun.
Yeah, there's
not
like a
closest to the sun,
definite-
but-
There's a definite change in
Exclamation line,
Venus
yeah.
and sci-fi,
Mhm.
and it's related.
To what
We'll
we
get
learned
to it.
about Venus.
We'll get to it. So,
Women
thanks
stop
for
being
joining
from
us.
Venus.
thanks for joining us. Join us in 2 weeks, the 24th of March,
Sure.
where we have High in the Sky for
Oh yeah,
April.
we will be on location in Bend, Oregon.
Oh, nice.
shit.
Okay.
Are we gonna
For
have
that
are we gonna have a
episode.
podcast?
Oh yeah, we're gonna.
I guess we're committed now.
I guess we're committed, so we
I
need to
think
remember
I'll
to bring our
be there.
podcast
We're
shit.
going on a road. We're going on a road. So,
We're
so
on
join us
assignment.
in. Remember to follow us on all the things. If you're with us now, please stick around
Stay with us, please.
for
We
the
have commitment
hangover.
issues. Stay with us.
That's God. It sounds like we're just begging, which we
Please.
kind of are.
Please,
Um,
please stay with us. I have no one else.
Lisa, can I have another viewer?
Oh,
All right.
nicely done.
Cheers, everybody. We'll see you in 2 weeks. Bye.